Identify each process as endothermic or exothermic and indicate the sign of delta H. Delta H is enthalpy of reaction, which, depending on when you're watching this video, we may or may not have talked about yet. It is basically just another way of looking at the heat of a reaction. So what we're trying to determine is whether the reactions presented here would require energy and be endothermic, or release energy and be exothermic. The first one is sweat evaporating from the skin. So in this process, we want to think about, well, what happens when sweat evaporates from skin? Sweat starts as liquid water, right? Essentially, that's the main component of sweat is water. And when it evaporates from the skin, it becomes water vapor or a gas. So what we're looking at is a phase change from a liquid to a gas. Going from a liquid to a gas requires energy. Liquids have less motion and are at a lower energy than gases, which have high motion and are a higher energy. So this process needs to gain energy. Gain energy means that energy enters the system. And so that makes this process endothermic. We feel sweat evaporating from our skin as cold. It feels cold to us because energy is leaving us and entering the water, which then uses that energy to evaporate. The next process is water freezing in a freezer. Again, we want to think about the process that's actually happening here. So water starts as a liquid and goes to a solid. Liquids have more energy and more motion. Solids have less energy and less motion. So in order to go from a liquid to a solid, we have to lose energy. That means that it exits. Energy exits the water. That makes this an exothermic process. The last question here is wood burning in a fire. So this is a little bit different. We are looking at a combustion reaction. And we could write an equation for the chemical reaction if we wanted to, but we don't really need to do that to think about this. We know how a fire feels. A fire feels warm. So hopefully we are not part of the fire. That'd be problematic. But if it feels warm to us, we are part of the surroundings. And that means that heat is exiting the fire. And that means that it is an exothermic reaction.